Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we are going to talk about a normal probability distribution. Again, we have turned the tables from talking about discrete probability distributions to now we're talking about continuous probability distributions. That means there are an infinite number of possible outcomes, all right? And so before we talk about the normal probability distribution, we first need to know what is the normal curve. The normal curve is a curve that looks like this, and we call it bell-shaped because it kind of looks like a bell if you look at it. And it goes up, it reaches a peak, and then it comes back down, all right? This is our normal curve, and if we have a model in which the graph of that model follows that shape, then we call it a normal distribution. So if you can see in all three of these models, if you look at them, they all follow a normal shape or a normal curve where it starts off low, it increases, it peaks, and then it starts to decrease at the same rate at the same rate in which it was increasing. All right, and the normal curve is a symmetric curve, meaning you could draw a line down the middle and you will basically get the same thing on both sides of that line. So that leads us into the normal probability distribution. And we say that a continuous random variable is normally distributed, or it has a normal probability distribution if its relative frequency histogram, which is basically what these are histograms, has the shape of a normal curve. So if you graph its histogram, and this is its frequency histogram, if it has the shape of the normal curve, then that is a normal probability distribution, all right? Normal probability distributions are symmetric about the mean. That means, you know, that line that I talked about, drawing down the middle of it that cuts it in half, that line is the mean. And then the data near the mean are more frequent in occurrence than data far from the mean. Alrighty. Now the empirical rule applies to the normal graph. And remember, the empirical rule said that most of your data is within 3 standard deviations of the mean. All right, now this image shows us that 1 standard deviation from the mean, and now those points that are 1 standard deviation from the mean are called your points of inflection. So this is the mean minus the 1 standard deviation. This is the mean plus 1 standard deviation. Those are your inflection points. Your mean is in the middle. That is your highest point on the graph of your curve, okay? Those inflection points are the points on the curve where the curvature of the graph starts to change. So you see it's going down and it kind of starts to change right there. All right. Now, when you change the mean and standard deviation, it's important you know how that affects the graph. So on this first graph right here, we have 2 different normal curves. On this first one, the mean is 0 and the standard deviation is 1. And on this second one, the mean is 3 and the standard deviation of 1. The only difference between these 2 curves is that they have a different mean. If you have a different mean, all it does is shift the graph either left or right, depending on what the means are. But notice the shape of the graph doesn't change. It stays exactly the same. So if the standard deviation is the same, but the mean is different, it moves the graph either left or right. It just shifts it either left or right. We call that a horizontal shift. Now in this example right here, we have this blue curve that has a mean of 0 and a standard deviation of 2, and this red curve which has a mean of 0 and a standard deviation of 1. In both graphs, the mean is the same. That's the line that goes straight down the middle of the graph, but the standard deviation is different. Notice that the standard deviation can change the shape of the graph. This high graph has a standard deviation of 1. This low graph has a standard deviation of 2. Remember, standard deviation is a measure of spread. It's a measure of, it's a spread measure. And so it's going to change how that graph is spread out. So the bigger the standard deviation, the more spread out your data is, which means the flatter your graph is going to be. So notice this one has a standard deviation of 2 and it's flatter than the one that has a standard deviation of 1, okay? So it's important that you know how the mean and the standard deviation will change your normal curve. And so some properties of the normal density curve is it is symmetric about its mean. Remember, the mean is right in the middle. That's your highest point. Now, the mean in a normal curve, the mean, the median, and the mode are all the same. And so the curve has a single peak, and the highest point that occurs is at that mean. So your highest point on the graph is at the mean. It has inflection points at the mean minus sigma and the mean plus sigma, which we just saw in the previous slide. The area under the curve is still 1, all right, because this is a continuous distribution, a continuous probability distribution. The area under the curve is 1. The area under the curve to the right of the mean is the same as the area under the curve to the left of the mean, okay? So everything above the mean, that area is going to be 1/2, because if your whole probability is 1, then if you only take half of it, that means the area under the curve that's above the mean is 1/2, and so is the area under the curve below the mean, okay? So you can cut your graph in half, and you'll have the probability to be 1/2 for everything below the mean and to be 1/2 for everything above the mean. As x increases without bound, it gets larger. The graph approaches but never reaches the horizontal axis, okay? And as x decreases without bound, it gets more and more negative. The graph approaches but never reaches the horizontal axis. All right, so that just means the graph never touches the x-axis. It gets really close to it. As it goes out on its tail, it gets really close to it, but it doesn't touch it. And then, as I mentioned before, the empirical rule applies, and that says that 68% of your data is between the mean and the first standard deviations. 95% of your data is between the mean minus 2 standard deviations and mean plus 2 standard deviations. So it's within 2 standard deviations of the mean. And then 99.7, which is almost all of your data, is within 3 standard deviations of the mean. So that means it extends from the mean minus 3 standard deviations plus the mean plus 3 standard deviations. So here is another picture of the normal distribution. Again, showing the empirical rule. So here's your mean. Within 1 standard deviation of the mean, 68% of your data lies. That's 34 on one side and 34 on the other, because when you add those together, you get 68. Within 2 standard deviations of the mean, you have 95% of your data. That's this 13.5 plus this 34 plus this 34 plus this 13.5. And then within 3 standard deviations of the mean, you have your 99.7%, which leaves 0.15% out here, everything less than 3 standard deviations from the mean, and 0.15% out here, which is everything bigger than 3 standard deviations from the mean. Again, earlier when it was saying that the graph, it gets really close to the x-axis, so as it goes out this way, it's going to get really close to this x-axis, but it's not going to touch it. And as it goes out this way, it's going to get really close to this x-axis, but it is not going to touch the x-axis. So let's look at an example. Here's an example of a normal curve, and it has some data points on it. What we want to do from this normal curve is identify the mean, the standard deviation, and the points of inflection, okay? So now remember, the mean is the number that's at the highest point, which is the number directly in the middle, which is 100. So our mean here will be 100. Now our standard deviation, since the empirical rule applies, this from here to here is 1 standard deviation. And from here to here is 1 standard deviation. So all you need to do is figure out what is the distance from either here to here or here to here. It doesn't matter which one you use. I'm going to use this one because it's easier. 115 minus 100, which is equal to 15. So that lets me know that my standard deviation is 15. So this is 1 standard deviation out. This is 2 standard deviations out. This is 3 standard deviations out. My points of inflection, I'm going to say POI for points of inflection. Those are the points that are 1 standard deviation from the mean. So here and here. So that happens at 85 and at 115. That's where the points of inflection occur. All right. So this is how you will look at the normal curve and find the mean and the standard deviation. and the points of inflection. All right, now it wants us to do two other things on this graph. The first one is to shade the proportion that is at most 85. So 85 is here. At most means it goes up to 85, but it does not exceed 85. So if I wanted to shade the part of the graph that's at most 85, yeah, I'm going to leave it zoomed in. That would be everything below 85. So imagine that's shaded in. I'm just doing it here with my finger. But at most 85 will be this region under the curve right here. Because at most 85 means it goes to 85 and it does not pass 85. Okay. So that was the first part, part A. Now part B, I have to zoom back out to do it. All right, so part B, it says shade the proportion that is at least 130. So here's 130. At least means it's 130 or bigger. So that means I'm going to be everything bigger than 130. Okay, but that's under that curve. So it doesn't go above the curve. It's underneath the curve, and it's everything that is 130 or bigger. Okay. And so this is just getting familiar with the normal curve and what it means. So the probability for everything bigger than 130 is that area that's under that curve. Remember, the probability now is the area under the curve. All right. So this is the normal probability distribution. We'll learn more about it in the next video, but these are just the basics of the normal probability distribution. If you have any questions, don't hesitate to ask. I thank you for watching, and I will see you in the next video.